Hello, and today we're going to be talking about algebra. More specifically, graphing and solving compound inequalities.
Alright, and as the name suggests, a compound or as the word compound suggests, compound inequality is a set of two inequalities that are connected with an and or an or.
Alright, so an example of an and inequality would be -1 is less than x, which is less than -2.
No, 2. Alright, so if we were to graph this, or which we are going to graph this,
We're restarting.
we'll take a graph, and then we'll plot the critical values, which is -1 and 2. As you recall from the last video, we'd have to use an open circle because it's less than, not less than or equal to.
And if you guys don't know what an open circle and a closed circle are, you can always refer back to our last video.
Alright. So, now, a common rule of thumb for graphing is that and is in between and or is outside. That means that and is in between the two critical values, and or means that you graph two rays that are outside of the two critical values, which we will show right now with another example.
So an example of an or inequality would be x is greater than 2 or x is less than -1. So to graph that, we would first plot the two critical values, -1.
Oops. Oh.
If our graph comes back, then we will.
I'll just make a new one. There.
So we would first plot the two critical values, -1.
Oops. I'm making a... Don't worry, just keep going.
-1 and 2. Now, as we said before, or actually, as Daniel said before, with an or inequality, you would take the or inequality.
You would write on the outside.
Yes, two rays would go in separate directions and not like in between, not like that part in between the two critical values. So, there are two separate rays that go into opposite directions, not to be confused with opposite rays, however.
Alright. So, and now we will talk about and we have to also talk about something that's a little confusing between and or. So, this is an and state, is an and inequality, right?
Yep.
This is an or inequality. Now they look so similar. What's the difference? The difference is that this one is basically two different inequalities, because you can't have something that is greater than 2 and also less than 1. Fine, you explain it then.
Alright, so
What? Okay. So then that means that 2 would be. That means that it would have to be 2 is less than x, or x is less than -1.
Because as Daniel just said, you can't say you plugged in 3 for x. 3 might be greater than 2, but however, 3 cannot be less than -1, making an or inequality.
Exactly. And a common rule of thumb for this is that if the second value is less than the first value, then it is an or inequality. Alright, now let's move on to a absolute value inequality. So, absolute value is the distance from 0. For example, the absolute value of 3 equals 3, because 3 is 3 units away from 0. The absolute value of negative 3 is also 3, because negative 3 is 3 units from 0. So, if we were to make it an inequality, absolute value of x is, I don't know, pick a number.
Is greater than 2. That is an OR inequality.
Because, as we know, since it's the distance from z is the distance from 2, that means that the
So good. So
distance from 2. Yeah, it's just you just give us like 5 minutes, please. Yeah, we know.
oh my god. You want to go to my house next time?
Yes.
Okay.
Daddy.
Okay, guys.
No. Okay, I'll just continue talking.
Suddenly.
No. It's like 5. It's 5 minutes at max. All right. So, yeah, like we were saying, absolute value of this would say that the distance between x and 0 must be greater than 2. That means that it can't be anywhere from negative 2 to 2. Because if so, then the absolute value would be either 2 or less than 2.
Okay, so moving on to and absolute value inequalities. So an example of that would be the absolute value of x is less than 2. And a smart trick to remember whether it's and or. If it is less than it is and if it's greater than, then it is or.
Yeah.
Pretty much true though, every time.
That's still an observation. Okay, never mind. We're getting off topic, and my friend is getting off topic. So anyway, so this is basically saying that the distance from 0 must be less than 2. That means that x must be in between negative 2 and 2. So if we were to graph, these, let's grab this graph right here. If we were to graph this, we would first plot our critical values. This was 0, and this would be one of them, and this would be the other. So what we'd have to do is we would have to go on the outside because it is an OR inequality. Wait, no. This is an AND inequality. So we'd have to go in between them, like so. Because anything from negative 2 to 2, in between those two, will be, the absolute value of it will be less than 2. All right. Well, and the opposite goes for the other inequality, for absolute value of x is greater than 2. That would be that it'd be on the outside instead of the inside. So that kind of concludes our video here. Stay tuned for our next video, which is graphing linear inequalities. And thank you for watching, and goodbye.